Space feels obvious. We move left and right, forward and backward, up and down. Three dimensions surround us every moment of our lives. But if you pause and think about it, this is actually strange. Why not two? Why not 10? And more importantly, why does space have dimensions at all instead of being formless or shapeless? To understand this, we need to start simple. A dimension is just a direction you can move in freely. Imagine a single point floating in nothing. It has zero dimensions because you cannot move anywhere. Stretch that point into a line, and now you can move forward and backward. That is one dimension. Add another direction at a right angle, and you get a flat surface like a sheet of paper, 2 dimensions. Lift that sheet upward, and you create depth, 3 dimensions. Each added dimension gives reality more room to exist, interact, and become complex. Our universe allows movement in 3 independent directions, and that is what we experience as space. We don't think about this because it feels natural, but it is one of the deepest facts about reality. The structure of space shapes everything, from tiny atoms to giant galaxies. Now imagine a 2-dimensional universe. Picture a world completely flat like a drawing on paper. In such a reality, everything would exist on a single plane. That might sound interesting, but it would be extremely limited. Complex structures could not exist the way they do in our world. Blood vessels, nerves, and organs could not cross over one another without colliding. Brains could not fold into layers. Creatures could not have true insides or 3-dimensional bodies. Even basic chemistry would struggle to function properly. For this reason, many scientists believe that stable matter and complex life require at least 3 dimensions. 2 dimensions simply do not provide enough room for a rich, structured universe. What about 4 dimensions? At first, this sounds even more exciting, more directions, more possibilities. But physics suggests that a 4-dimensional space would be unstable in important ways. Gravity would spread out too quickly, making it hard for planets to stay in stable orbits around stars. Atoms might not hold together in the same way, which could prevent chemistry as we know it. Stars might not form or burn steadily. Instead of being richer, reality could become chaotic and short-lived. 3 dimensions seem to sit in a narrow balance, just enough room for complexity, but not so much that everything falls apart. We usually imagine space as empty, like a blank container where things exist. But Einstein showed that this is not true. Space is more like a flexible fabric that can bend and stretch. When a massive object like the sun sits in space, it curves this fabric around it. Smaller objects like planets then move along these curves, which we experience as gravity. This means dimensions are not just abstract directions, they are part of the physical structure of the universe itself. Space is not passive. It actively interacts with matter and energy. If we zoom in far enough, space becomes even stranger. At human scales, it looks smooth and continuous, but at extremely tiny quantum scales, space starts to behave more like a restless sea of energy. Particles appear and disappear. Empty space flickers and vibrates. Nothing is perfectly still. This suggests that dimensions might not be built into reality from the beginning. Instead, they could emerge from deeper microscopic processes, much like temperature emerges from the motion of countless tiny particles. Some theories in physics, especially string theory, suggest that space might actually have far more than 3 dimensions, possibly 10 or 11 in total. We do not experience these extra dimensions because they are tightly curled up at incredibly small scales, far beyond anything we can observe directly. A helpful analogy is a garden hose. From far away, it looks like a simple line, 1 dimension, but if you zoom in, you see that it actually has a circular dimension wrapped around it. Our universe might work in a similar way, with hidden dimensions wrapped up inside every point in space. Right after the Big Bang, the universe was extremely hot, dense, and chaotic. It is possible that space did not clearly have 3 large dimensions at that time. As the universe cooled and expanded, 3 dimensions may have grown large and spread out, while others remained tiny and compact. If this is correct, then the dimensional structure of space is not permanent. It is the result of cosmic evolution over billions of years. There is also a philosophical question here. Some thinkers argue that dimensions are not truly features of reality, but simply ways our brains interpret movement and distance. However, physics strongly supports the idea that dimensions are real because forces like gravity, light, and electromagnetism behave according to them in precise mathematical ways. The universe responds differently depending on how many dimensions there are, which suggests they are not just mental constructs. 3 dimensions allow stable atoms, long-lasting stars, predictable gravity, and rich chemistry. These conditions make planets, water, and life possible. If space had been structured differently, the universe might have been lifeless, chaotic, or short-lived. Our 3-dimensional world is not random. It is finely tuned in a way that allows complexity to emerge. So why does space have dimensions at all? Because without them, there would be no structure, no motion, no matter, and no universe as we understand it. Dimensions provide the framework in which reality unfolds. Whether they are fundamental building blocks of the cosmos or emerging properties of deeper physics, they shape everything that exists. Every step you take, every breath you draw, every star you see in the night sky happens inside this invisible dimensional framework. We rarely notice it, but dimensions are the silent architecture of existence itself.